Okay, so I did the soaking the gummy bears in water and salt water experiment. And I did it for about, say like 7.5, 8 hours. So here I have them right here. Don't know how to turn it. Here's salt water, and this is just the distilled water. So I'm gonna get them out. And I actually did gummy worms because I couldn't find gummy bears. So we'll see if that made a difference. Yuck. Salt one ended up breaking into 3 pieces, so. Okay. So, this was the gummy worm to start. Just a normal gummy worm. This one was the one that was soaked in salt. It broke into 3 pieces. And this one was the one that was just soaked in in the distilled water. This one, the one that was soaked in salt, is still pretty expanded, but it's noticeably smaller than the one soaked in just the distilled water. So in doing research for this experiment, basically the point of the experiment is the salt solution, because there's so much salt in it, it tends to draw the water out of the gummy bear, so it should shrink it more. I don't know if the fact that I used gummy worms or just the amount of time I used it, or you know, the salt to water ratio was off. So I think ideally it would be shrunk. It would shrink smaller than this. But the point of it is the salt is supposed to draw the water out of the gummy worm, which will shrink it, whereas soaking it in the distilled water is pulling the water into the gummy bear and, you know, expanding it. So it's turning, it's a lot of water in there. So I think if I would have done a better job at doing a better salt to water ratio and getting the proportions right, figure out the time better, and maybe checking it throughout more to see if, you know, I did need more salt or whatnot to make it smaller, or to make it shrink would be better. But this is an example of a hypertonic solution, so there's that.